The gap between curiosity and controlled experimentation is where advantage compounds. Welcome to AI on AI, where smart AIs argue about smarter AIs. Today, autonomous data agents turning messy data into actionable knowledge. Buckle up. It's like teaching your data to think, talk, and file its own paperwork.
Right? We're talking agents that perceive datasets, plan workflows, call tools, generate code, and iterate end to end. Not just chat, but act, reflect, and deliver.
Technically, think perception, planning and decomposition, action reasoning, then grounding and execution. RAACT for loops, COT for clarity, MCTS for look ahead, plus memory, short-term for steps, long-term for playbooks.
Love the elegance, but enterprise realities bite. Dual roles, planner and actor, often beat single monoliths for governance, observability, and cost control.
And none of this flies without privacy and guardrails. Least privileged data access, prompt injection defenses, and code analyzers that stop, delete from everything moments.
Quick pulse check. Recent developments making this feasible.
Smaller, more capable models got better at function calling. Open orchestration frameworks matured. Agent workflow benchmarks started appearing. Tool use has gone from novelty to dependable.
Strategically, the stack is shifting toward data fabric plus agents. Procurement's moving from buying models to buying workflows that interoperate and audit cleanly.
Contrarian here, for a lot of pipelines, a disciplined ETL with rules still beats agents on predictability, cost, and compliance. Determinism has a business model.
Architecture in practice. How do these pieces click?
Perception profiles schema, distributions, and lineage. Planning decomposes tasks. Action reasoning selects tool calls or code. Grounding validates types, names, and signatures. Execution runs with feedback loops.
Memory ties it together, retrieve similar past fixes, avoid repeating failed steps. It's like not touching the hot stove twice, but with column encoders.
The planner outlines retrieve, clean, join, aggregate, visualize. The actor specializes in each subtask. Think air traffic controller and the pilots.
Grounding often means executable code, SQL for joins, Python for transforms, plotting libraries for charts, with dry runs, schema checks, and tests as breaks.
Guardrails run alongside. Sandboxed execution, outbound network limits, PII screening, and policy checks before write operations. Measure twice, cut once.
Use cases, bring it to life.
Hospital admissions forecasting. The agent cleans timestamps, imputes missing vitals, runs time series models, attributes seasonality, and outputs staffing suggestions with uncertainty notes.
Retail anomaly detection. It segments weekly revenue by category, flags dips week over week, correlates with promos or stockouts, then drafts a concise executive summary.
Finance reconciliation. It reads ledger tables, aligns schemas, spots breaks with rule-based checks, then asks for human approval on risky adjustments. Tabular QA closes the loop.
Manufacturing sensors. It denoises streams, repairs outliers, and standardizes units before predictive maintenance. It's like tuning a noisy guitar before the concert.
Sound slick, also sound expensive.
Funny enough, agents can route cheap first. Profiles, heuristics, tiny models. Only escalate when needed, like an intern that never sleeps but remembers linting rules.
Training, what's under the hood.
Instruction tuning on multi-skill datasets, preprocessing, feature engineering, text-to-SQL, visualization, repairs, tool calling paired with execution traces. The how, not just the what.
Then reinforcement fine-tuning using execution rewards, success rates, valid artifacts, correct SQL results, chart specs. Agents learn from running, not wishing.
Benchmark gaps remain, especially for task decomposition and repair actions. We need shared, realistic workflows, not toy prompts.
Pushback RFT can overfit to sunny day playbooks. Hallucinated joins and silent truncations still happen. Without deep observability, you're debugging spaghetti code in the dark.
That's why we ground hard. Dry runs, determinism checks, schema diffing, row count invariants, and unit tests on transformation functions. If it can't pass, it can't ship.
Cost-performance trade-offs. What's the playbook?
Route by difficulty, simple stats with templates, medium tasks with small models, complex chains with planner actor. Good input, good output, but also small hammer first.
Keep classical baselines handy. Sometimes a linear model plus tidy features beats a heavy agentic stack. The best tool is the simplest one that works.
Workflow optimization matters. Search-based look-ahead versus heuristics. Filter early, aggregate late, minimize joins. It's pipeline Tetris.
Memory and reuse, friend or foe?
Both short-term keep step coherence. Long-term stores successful repair trajectories and query patterns. Summarize aggressively, forget strategically.
And enforce retention, windows, encryption, and scope-limited recall. Memory shouldn't become a shadow data lake.
Multimodal context beyond tables.
Yep, charts, images, logs. Visual models can parse charts and compare with tabular results. A unified JSON info box ties modalities together for reasoning.
On capabilities, symbolic equation extraction is rising. The agent proposes forms, fits, and prunes for parsimony. It's scientific method, but on rails.
Careful symbolic forms can seduce. Wrap them with unit tests, out-of-sample checks, and constraints. Otherwise, it's poetry, not physics.
Governance. What keeps this safe and sane?
Action guardrails, code scanners, runtime monitors, approval steps for writes, and audit logs. Also, red team prompts for jailbreak detection and recovery plans.
Organizationally, roles shift. Analysts curate prompts and checks. Engineers assemble toolboxes. Governance teams set policies. Data analysts become air traffic controllers of workflows.
Near-term predictions.
Data agents will fuse with data quality platforms, becoming always-on validators that propose fixes and draft rollout plans. Buying cycles will center on interoperable workflows.
Teams of agents will outperform solos. Planner, critic, executor, verifier. Fail fast, learn faster, but with Rails. Expect lighter models with stronger tool use.
Don't rip out your ETL. Start narrow, repairs, text-to-SQL report generation, prove reliability, then expand.
We'll see shared agent sandboxes and common evaluation suites, so apples-to-apples comparisons finally exist across industries.
And data contracts will be first-class citizens. Good input, good output stops being a slogan and becomes an enforceable interface.
That's a wrap. Agents aren't magic, but with planning, guardrails, and sharp tools, they're a step change. Thanks for listening to AI on AI. See you next time. Stay with us for a concise summary of the highlights.
Narrated by the AI voice of Shri. The main theme is a new class of autonomous data agents that turn raw data into usable knowledge. The question is how to automate end-to-end data work with intelligent systems. Researchers propose autonomous data agents that can plan, reason, and act on data. A data agent blends language understanding, task planning, action reasoning, tool use, and execution. The aim is to make data think, speak, and act through software workflows. Manual data tasks are repetitive, error-prone, and difficult to scale across formats. Simple prompting of large language models cannot reliably plan, decompose, and execute complex workflows. The agent first perceives the data and the request to understand what needs to be done. Schema means the structure of tables, columns, and types that the agent must read. Planning and decomposition break a high-level request into smaller, executable steps. Action reasoning chooses the next move using step-by-step thinking, simulated search, and reflection. Memory helps the agent avoid repeats and improve choices across steps and tasks. Short-term memory tracks recent actions within a task. Long-term memory stores past trajectories that help with similar future tasks. Action grounding converts abstract steps into concrete code, database queries, or tool calls. Grounding means translating ideas into executable operations that fit the actual environment. Execution runs the code, observes results, handles errors, and iterates. The action space includes tool calling, symbolic expressions, and direct generation of summaries. Symbolic expressions include structured queries and data transformations that systems can run. Data can be represented as text, as visualizations with text, or as a structured key-value format that mixes modalities. Training uses instruction tuning on datasets that pair natural language with execution traces. Skills include preprocessing, feature engineering, data augmentation, visualization, text-to-database query translation, and equation discovery. Agents also learn task decomposition from annotated plans with steps, dependencies, inputs, and outputs. A single agent design unifies planning and execution in one model. A planner-actor design separates planning from execution for clarity and control. Reinforcement fine-tuning improves planning and actions using rewards from successful runs and correct results. Policy gradient methods such as proximal policy optimization can update the agent based on rewards. Realistic prompts include analyzing Arizona retail sales and compiling a visual report. Another example forecasts hospital resource needs by cleaning records, modeling demand, and summarizing recommendations. In tests on public datasets, the modular agent outperformed classical methods and pure language models. On a German credit classification task, it reached 79.6%, above all baselines. On a regression task, it scored 0.783, also the best among compared methods. It completed tasks with about 2 calls on average and needed no extra training time. Experts debate the cost and safety of decomposition, which can sometimes bypass guardrails if unchecked. There is tension between deep search for optimal workflows and the need for fast, affordable processing. Key challenges include open benchmarks for multi-skill training and reliable action grounding. Additional hurdles include tool versioning, error recovery, and effective memory management. Privacy protection is essential during training and during user interactions with sensitive data. Strong guardrails are needed to prevent harmful queries, unsafe code, or unauthorized data access. Future work aims to optimize action workflows, refine routing and planning, and build reusable memories. Better datasets for decomposition, feature engineering, quality assessment, and repairs will accelerate progress. These agents could turn messy, multi-format data into trustworthy knowledge at scale for everyday analytics. Save someone a month of trial and error, send them this conversation.